Alright, so what quadrants are inverse trig functions defined in? So you should know something about inverses first. So all functions have inverses, but not all inverses are functions. So if I have, let's just say y equals x squared, well, this has an inverse. Remember, inverses are symmetrical of the line y equals x. Okay, so it would look like this. The inverse of that is not a function because it fails the vertical line test. So how do I know if the original function is going to have an inverse that's a function? It has to be 1 to 1. This parabola is not 1 to 1 because it fails the horizontal line test. Try to stay focused. Here we go. Okay, so, oh my gosh. In order for a function to have an inverse that is a function, I'm about ready to start over. Okay. It has to be 1 to 1. It has to pass the horizontal line test. Okay, so if we look at y equals sine x. So y equals sine x looks like this. Goes forever. So if I wanted to find its inverse, and I wanted the inverse to be a function, we can't use the entire y equals sine x. We can't use the entire domain because it's not 1 to 1. It'll hit in multiple places with a horizontal line. Okay, so what we do in order for it to have an inverse that's a function, we just use part of it, a 1 to 1 portion of y equals sine x. Okay, so if I started at 0 and went out to pi, that's not 1 to 1. So what we can do is we can go from negative pi over 2 to positive pi over 2, and that chunk of the graph, if we ignore everything else, that much of it is 1 to 1. It passes the horizontal line test. Okay, so we say that we're going from negative pi over 2 to pi over 2. Well, on the unit circle, that means we're going from negative pi over 2 to pi over 2. We're not going beyond pi over 2 or before negative pi over 2. So we're only going to be in quadrants 1 and quadrants 4 for inverse sine. If you get a positive, so inverse sine of a positive number, it's going to be quadrant 1. Negative would be quadrant 4. Okay, that also works for tangent, that interval, because tangent is a repeated curve that looks like this, goes forever, so it's not 1 to 1 through the whole domain. But if we just take one of these curves from negative pi over 2 to pi over 2, that'll work. So inverse sine is positive up here, inverse sine is negative down there, only defined in these two quadrants. Inverse tangent, if positive, is up there, inverse tangent if it's negative. So what I mean by negative, if you take the inverse tangent of negative 1, what quadrant are we in? Well, remember, inverse trig functions means what angle has a tangent of negative 1. Well, this has a tangent of negative 1. This has a tangent of negative 1. But we're only in quadrant 4 for inverse tangent. So right down here, our answer would be 1 square root of 2, and that one's negative. So it'd be negative pi over 4. You can't say that the inverse tangent of negative 1 is 7 pi over 4, even though 7 pi over 4 gets a tangent of negative 1. 7 pi over 4 is not defined for inverse tangent. It's just going from negative pi over 2 to pi over 2. Cosine is different because cosine, the characteristics of the graph, it starts here, and it goes up, Kind of looks like that. So if we went from negative pi over 2 to pi over 2, that's a portion that is not 1 to 1. So we have to use a different portion. So we just say, let's start at 0 and go down to like right there. And that's where you can stop it. So it's from 0 to pi. If we went beyond pi, it's no longer going to be 1 to 1. So inverse cosine, remember we're going from 0 to pi, inverse cosine exists in quadrant 1 and quadrant 2. If it's positive, inverse cosine is in quadrant 1. If inverse cosine is negative, you're in quadrant 2. And cosine inverses, and what quadrant they are defined in.